Maintaining application security can be a challenge that may result in false positives. Ideally, you want to identify and tune what is actually relevant and valuable to the application itself. In this demo, we combine WAF and RASP using an application delivery rule to flag a suspicious attack. RASP will validate that the web application on show is actually vulnerable to an attack defined by a WAF rule. The user will set a rule in alert mode and add an ID to a custom header. RASP is also set to send events to a SIM, including the header with the ID. The user can then use the SIM events to verify that the rule actually defines an attack that is applicable to the application, as it was detected by RASP, and therefore can set the rule to block in the WAF. Imperva's Cloud WAF is a great product. However, there may be some attacks which may not be blocked out of the box. Imperva's Cloud WAF is configured this way mainly to avoid false positives. To simulate an example case, we will set SQL injection mitigation control to alert only. The user may want to create a custom rule and set to block mode from this application-specific attack later. However, they may be worried about those false positives. As such, they are only willing to risk blocking this type of attack if they know that the application is vulnerable to this type of attack. Luckily, even though WAF is in alert only for SQL injection attacks, the application is still protected by RASP. This can be observed from the blank page that is returned after this SQL injection attack attempt. It is important to note that one of the main differences between RASP and WAF is that WAF protects from theoretical attacks, whereas RASP inspects the attack from within the application, examining potentially nefarious requests and payloads as they would otherwise be handled by the application code. RASP can be used in this way to enable the app to self-protect, adding another layer to a defense in-depth strategy. Or, as demonstrated today, RASP allows organizations to gather the information needed to create new WAF rules which can be tested, giving organizations the confidence to switch from alert mode to block mode. Now, let's look at an example of how we can leverage WAF and RASP together to protect applications from attacks. First, we will create a security rule in WAF for the specific attack which the customer is concerned about. Second, we will enable the rule and set it to alert mode to avoid false positives. We will only move it to block mode when we are sure that the app is vulnerable and enabling the rule is worth the risk. Next, we will create another rule with the exact same condition as the previous rule, except that we will set a cookie rewrite action, adding a new cookie. The value will be the rule ID, so when the attack occurs, WAF will add a custom cookie that points to this rule. Now, returning back to our application, when the attack occurs, our new rules trigger, and the attack is alerted by WAF and blocked by RASP, as we see from the blank screen again. In this demo scenario, like with many of our customers, RASP is configured to send events to Splunk. So let's look at the RASP Splunk application for more information. If we drill down into the last event logged, we see details of that event, and if we drill down further, we see that our custom cookie from WAF had been captured in the RASP event. Now that we have seen the evidence in the RASP event, we can be sure that the app is actually vulnerable to the attack. In this scenario, we set the cookie value to a specific rule ID to correlate the attack to the relevant rule in WAF. So now, feeling confident about the validity and applicability of the rule, we can now go back to WAF and switch that rule from alert to block. Switching the rule to block in WAF pushes attack protection back to the edge, minimizing risk to the application. This approach maximizes Imperva's defense in-depth strategy by providing protection as close to the edge as possible while having the assurance that what's being blocked is actually a real risk since it's been verified by both the WAF rule and RASP.